Hi guys and welcome. I'm Julia Żywiecka and today we are diving into a topic that affects every factory no matter the product, water. In high-tech manufacturing, wastewater is not only a massive environmental issue, it's also an opportunity. At Smart Factory Design, we build integrated systems that recycle, clean, and reuse industrial water, saving money, reducing emissions, and keeping production efficient. With me is our founder and CEO Alexander Stepinski to explain how we make it work and why this technology is no longer optional. So let's start with the core, Alex. What kinds of wastewater recycling designs do we offer at Smart Factory Design?
Well, we offer all different types. Originally, I invented a central recycling concept, so it got rid of all the water usage of the PCB fab, got rid of all the discharge, and done a few generations on this, and this is the primary tool that people are interested in to get rid of their permits, to recycle all the water internally. But then we also offer individual chemical recycling systems for different applications, whether it's an etchant, plating chemistry, a cleaner, a micro etch, a pre-dip. I would say developer, resistor. I would say about 80% of the chemistries in a circuit board factory can be recycled with the technology currently available in the market. So we have designs for all of these applications. We have designs for recovery of circular economy products for reuse in the process. And that's kind of our portfolio.
Yeah, so it's not just about filtering water; it's a full circular process.
Yeah.
For people outside the industry, it might sound surprising. So why it's such a big issue in manufacturing right now? Like, why is wastewater recycling so important today, especially in sectors like PCB or electronics?
Well, there's two reasons. One reason is the traditional issue is the regulatory side. So if you can get rid of the wastewater discharge and even the air emissions, which we also offer solutions for that, you're able to reduce your permitting requirements, reduce your regulatory burden, and then you can build factories or operate in places that maybe you couldn't without that enhancement. So that's one aspect. The second aspect is it's just waste. How do we when you have waste that's full of metals, when you have water, why can't you economically reuse these things? That's the question. And when you step back and think about it, I realized that nobody really gave it much thought. So they would just make some waste and get rid of it, discharge the water, ship some sludge off somewhere, ship some drums off somewhere, and there's a lot of cost to this. So I just always have seen this as a big opportunity for cost reduction if you do it the right way. So our systems are all profit making. We don't sell systems that are cost burdens, that are expenses. So it's a completely different model than the regular market. We don't do green technology for the sake of green technology. When I originally invented these closed loop systems, it was for the regulatory reason. We couldn't have a factory without it. But after that effort, now I had to re-engineer everything for the 99% of the market that doesn't have that requirement. And now our systems are all profitable. So short ROIs, there's capital associated with it, of course. But everything makes some kind of product, or it's reused in the process, or it makes something you can sell at a good price, and that's our focus.
Oh, yeah, I think it's one of those invisible problems. Like, no one sees how much water factories use, but the impact is huge. So let's talk about impact on the client side. What are the actual benefits of installing these systems?
So, you look like a much better corporate citizen when you don't have any wastewater coming out of your process. It's one of those things that's not discussed very much because it's kind of a big secret. So what you'll find is that our factories are all green because we have solar panels on the roof, and our factories are green because we're saving energy somewhere. I'm like, okay, but you also output millions of liters a day of toxic wastewater, and if you drank it, every day, you'd be dead in a week, right? And you're just relying on dilution and wherever you're putting it to clean it up. And most of the primary treatment processes that the municipalities offer are not effective against most of the chemicals in there. And then when you discuss it that way, well, that's a big problem. Nobody wants to have a problem like that. So if it's a big corporation and you explain it this way, well, the only solution is the green solution. Okay, but it has to be economical too. It has to be economical too. So that's where we focus on economical green solutions, and we deliver it in many different ways. The primary way is we sell a design, and then we help them with commissioning, and then if the customer isn't capable of executing the design on their own, or we have doubts that they're capable of doing it on their own, we're worried about reputational risk or something like that, then we have an integrator in every region who can do it for them. That's what we offer.
Yeah. Okay. So I think so it's like a win-win, sustainable and cost effective. But I imagine every factory has a different water footprint. So how do we adapt these systems to different scales?
Oh, the systems scale very well. So strong scaled economies on the systems, and it's because at the current state of evolution of the technology, the individual subsystems, the most economical size tends to be a little larger. And so what we find is that the ROIs in East Asia can be even less than a year on a system. The cost savings is so high with our latest design architecture. In Europe and North America, it's less. If it's a mass production facility in Europe and North America, okay, it's going to be similar to the Asian scale, but we have more high mix NPI type factories in these regions. So in this case, you're talking like 2 to 7 years, depending on the scale of the project. The smallest is 7, the largest in a high mix North American, European shops typically 2. But the systems that we develop, they're good for 20 to 30 years.
Yeah.
So, over the life cycle of the system, you have to look at it this way. You're gonna save a lot of money, and you're gonna reduce a lot of risk for yourself as a business owner, because you don't have to worry about someone coming in and shutting you down because the regulations change 7 years from now and they're not happy with what you're doing, and they realize that it's poison whatever you're putting in the water, and it didn't rain for a year and all the fish died, which happened on the German-Polish border not too long ago, where we had a fish kill despite all the effluents being inspected. It didn't rain for a while, and we had toxic algae bloom kill all the fish, all due to high salinity levels from industrial effluents. So that kind of flexibility is key, especially with regulations changing so fast. Yeah, also, with existing operations, we can adapt these systems very easily. So we can reuse a lot of the equipment that they have often, repurpose it for different parts of the process. And our systems tend to be only about a quarter the size of what traditional systems are. So usually we can fit it in. So that's the customization we typically do.
Okay. Yeah. So can you walk us through an example, a project where we help a client solve a major water issue?
I would say all of them. I would say nobody comes to us unless they really want this to go away. This risk to go away off their plate. They want to remove it from their plate, this risk.
Okay.
But there's different benefits. So the primary reason so far has been regulatory. With the latest system architecture, now we're seeing for the first time that people are looking at cost savings and making money from their waste. But another aspect is when you have closed loop systems, you have the potential to have unlimited water. So it's a different paradigm than what we've had historically. The industry paradigm is minimize water consumption, stop using water, and all the machinery is designed for this. So you have a whole ecosystem that's been developed on choking down the water supply. And as a result, you get into this trade space with quality, where you have to clean the machines more often because there's saltier materials in there that need additional cleaning. The boards are not as clean potentially. Let's say the process window is smaller when you have water minimization practices. With closed loop systems, if you design the factory and the wastewater system at the same time in the right way, you can have unlimited water. It's a totally different mindset. And this allows many things. Now you don't have to clean the equipment as much. Now the boards are much cleaner. Now there's less chance of having one-off defects There's less chance of having insulation resistance failures on internal layers because of some spec that got redeposited. That spec's more likely to dissolve in a high flow situation where you're turning over the water faster. Also, all of our systems are ultra pure DI water, so it has great properties for absorbing this kind of contamination that can redeposit and things like that. Even we use the DI water from our systems to keep the fume scrubbers super clean, so the emissions don't come out. And so that's one aspect of the closed loop. The other aspect is if you put it on the processes and you're recycling chemicals and doing things individually, there's some strange regulations you can avoid in some cases that apply to specific processes, depending on what country or state you're in. And also I would say, the big benefit is just capability. When you close loop something, you have the ability to improve the capability. It's a more stable process if you do it the right ways.
Yeah, it's such clear examples of turning a problem into a smart solutions. Yeah, so it's really about building responsibility into the design.
Yeah.
Okay, so thank you, Alex. Wastewater is one of those challenges that it's often ignored until it becomes a crisis. But smart design means thinking ahead. In our next 2 episodes, we will go deep into economics. First, how we help clients make smart investments using advanced analysis, and then how we perform global due diligence before anything is even built. So stay tuned, and not just engineering, it's strategy. Thank you.
Thanks.